Alrighty. Hello, hello. Let's do a quick AV check to make sure things haven't broken since I last was doing this in last term. Yes, chat relay. Hello, hello. Audio okay? Okay, that's good news. Video okay? That's also good news. All is good. Awesome. Hello, everyone. Wow, it's so nice to see. There's plenty of familiar faces and certainly some new ones too. Video is not 8K Ultra HD. I am so sorry. Funnily enough, I actually wouldn't get a choice on that because we've got YouTube ultra low latency mode, but it doesn't support even 1440p. And that's too low a resolution for Dong, it seems, sadly. Welcome, everyone. Woo! So, what time is it? It is 05:51. All right. Well, let's get started then. So, we're finally here. COMP6991, 22T3. So, I would assume that a huge portion of the course is aware that this is a completely brand new course, but there may still be some of us who, just saw this elective pop up and go, okay, great, I'll take this. So if you weren't aware until now, COMP6991 is a completely new course. You are here at the very first lecture of any COMP6991. It's been a couple of years in the making, as Shrey mentions. And so we've been sort of working on this for a long time, but regardless, it is still a new course. We're going to do our absolute best in all manners regarding this course, but it's still brand new, and there's still going to be some things I'm sure that go wrong, and so you might have to exercise a little bit of extra patience with us this term, but we really will do our best, and we really hope that you enjoy the course and get something out of it. And so welcome to COMP6991. So our lecture today is 2 hours. We have another lecture this week on Wednesday at the same time. This lecture, we're going to spend just introducing the course, some of the ideas behind the course. I'll probably end up going on a couple rambles and rants as we wander our way through this. And we'll also look at some very Rust basics. We'll do a little bit of programming. We'll do a little bit of programming, and we'll look at our first little bit of like theory almost. A lot of the sort of theory in this course is not necessarily us meaning, me and the teaching team, telling you this is a concept, write this one down, learn this, and we're going to assess you on this in the final exam. A lot of the theory in this course is really going to be, here's something to think about. Really, it's going to be, we've played around with lots of different programming languages and looked at lots of different features and ideas. And there's certainly patterns that prop up in, sometimes this feels like a better way to do things. Sometimes this feels like, this might be a little dangerous. And hopefully most of the time in this course, we're not going to come to you with the answer. We're not going to come to you and say, okay, so there's let's say functions, and functions should work this way, and if you do it like this, then you're doing it wrong. If at all possible, we're going to try and avoid that kind of thinking and instead go, here's 3 different ways of using functions. Here's what we think might be some advantages. Here's what we think might be some disadvantages. Try each of these ways, see how you like it, and try and take that knowledge and apply it more generally. Think about how this might look in a different programming language, in a different context. If you're, next year you're working at Google, how is what you're doing here going to help you think about how to program once you're out there? And so we're going to try and look at things quite generally, and you're very free to form your own opinions, and you're free to form your own ideas and ideals. And we're really going to try and encourage that as much as we can. So a lot of the course is going to be, you go away, do something, and when you come back to us, instead of us going, okay, so you decided on this one, right? It's going to be us prodding questions at you and going, what did you like? What didn't you like? Would you do it this way again? Is there sometimes you would do this and sometimes you would do that? How does this compare to different languages? We're going to be asking you those kinds of questions, so come prepared. Prepared not like with, the answers to say, but prepared to, think about these things, think critically about the way you program and the languages and tooling and all that sort of stuff you make use of. So we've got a whole course ahead of us. I don't want to get too hung up and too far ahead before we just get started, but this is sort of the primary pedagogical nature of this course. Pedagogical meaning sort of how it functions educationally, right? Don't expect a course where we're thinking like mathematically and this is the mathematical correct answer. Think of a more abstract course where we're asking questions and getting you to think about things and be critical, and it's really up to you to take those lessons and try and apply them elsewhere later, anything like that. All right, as I'm sure most of us have already figured out, there is a lecture chat, and your little chat does pop up on the screen and stuff like that. So please do send messages and questions. I'm not going to immediately be able to you send a message and half a second later I'm answering it. But I probably will pause every now and then to go through the live chat. Questions are awesome. And often when you're thinking of a question, even if, people always say, oh, everyone else in the room is probably thinking it. Even if they aren't, chances are it's probably going to be helpful to everyone regardless, because this is really what this course is all about. So if you have any questions, anything like that, if you have comments that you want to make, even if it's not a question, it's, we'll look at different programming languages in this course, and you might have experience with some programming language that we didn't have time to look at, or that, I might have even, I might not have thought of to introduce somewhere. And you might go, oh, I've used Lisp and there's some really interesting part of Lisp that, applies to this, or, I've used some other crazy language that, whatever. If you have things you feel like this could add something to a discussion, type it in, let us know. It's really, again, what this course is all about. So, all right. Okay, so the audio is good. Ferris plushies. Is Rust more difficult than C++? That's an interesting question. And it really will come down to your frame of difficulty. I'm going to leave that question unanswered, and maybe in week 10 you can let us know what you think. Once we've spent quite a bit of time with Rust, you can let us know. I'm assuming you sort of know some C++ at this point, but assuming that's the case, let us know again in week 10, and we might have a bit of an answer. Crabs, yes. Zach saying maybe sometimes it's something we might explore. Yeah, cool. YouTube Crab Dong doesn't like C++, and how to add right shift. Oh no, not right shift equals. I'm guessing that's monadic bind. Interesting. So we'll get to all these kinds of things. Yeah. But I won't jump too far ahead. So let's see what we got. Oh, I've got some quotes to start us off. Right. So I've got some absolute legends who are going to pass on a little bit of wisdom before we get started with the course. So Dijkstra, Dijkstra of Dijkstra's algorithm, and who really laid some absolute foundations in concurrency, says that a programming language is a tool that has profound influence on our thinking habits. Right. Interesting. Profound influence on our thinking habits. All right. Our next quote comes from Hal Abelson of Creative Commons and the Free Software Foundation, who says, a powerful programming language is more than just a means for instructing a computer to perform tasks. Right? This is probably the definition we got in COMP6991 or something like that. The language also serves as a framework within which we organize our ideas about processes. And finally, Larry Wall of the Perl programming language. Computer language design is just like a stroll in the park. Jurassic Park, that is. So Larry invented the programming language Perl, which has a reputation for being a sometimes questionable language. So Larry Wall certainly has a lot of experience in computer language design, and he's telling us that that it's computer programming language design is a very nuanced and tricky idea. But I really like this quote as well, because it sort of plays at the idea that until relatively recently, there hasn't been much like widespread discourse about programming language design. The academia has always been like, endlessly frustrated at the industry for all these languages that have been spit out, with all these foot guns and safety hazards and just being generally difficult to use in some ways. So there's a lot of learning that we're going to try and take on during the course. The read only, yeah, I think write only is the joke that people make, or execute only as well. Yeah, that's for sure. Where is Rust used? That's a great question. Miguel's got an answer there. Mainly systems programming. Rust can be used all up and down the stack. It is particularly suited for systems programming because it encapsulates a lot of these ideas in systems programming that can sometimes get in the way if you're sort of thinking on a higher business level. But I've seen it used all up and down the stack. Anywhere, say like C++, or maybe even C could be used. You could certainly find Rust in those areas too. Okay, so let's get on with some Administrivia then. So some nice quotes to think about, then and hopefully after the lecture as well. Just keep them in your mind. So the staff, the convener of the course is Dr. Andrew Taylor. Andrew won't really have much to do with the course this term, unless things go horribly wrong, which I'm not planning on. But Andrew is technically the overarching continuing staff responsible for this course. If you have some sort of grievance about the course that you don't feel is appropriate to pass on to me, and you're always welcome to pass anything like that on to me, whether I've done something wrong or it's anything surrounding the course, you're always welcome to pass that on to me. But you can also feel free to email Andrew or anything like that. But he's not really going to have any direct involvement with the teaching of the course or anything like that. I'm your lecturer. Hello, yes, I'm Zach. We have our two admins, Shrey and Tom, who have been putting in a ton of work behind the scenes, putting together like teaching materials and helping think about the course and ideas about the course. Shrey has particularly been involved in the weekly exercises, so I'm sure you'll see like in the examples and stuff, Shrey's name popping up all over the place. Because so he's been putting in a lot of work on the weekly exercises we'll look at in a little bit. And Tom has been looking in particular at the workshops and also assignment work. That's not to say that's the extent of the work they do, but that's what their main focus is throughout this term, what they're working on. We also have some wonderful teachers. We have Sage, Kaiki, and Jared, who will be joining us in the workshops, which we'll also talk about in a little bit, but less involved in the actual administration of the course itself. So yeah, we'll talk about workshops in a little bit. So what is COMP6991? Well, until now, hopefully, you've done lots of programming, right? Ideally, you've tried out multiple languages. Not every single person enrolled in this course will have tried out multiple languages, and we'll work with you and we'll help you through that. But I think if you've touched multiple languages, and especially if you've touched languages in different styles, right? If you've used something like C, if you've touched something like object-oriented, if you've maybe played around with some functional ideas, if you've done low-level code, high-level code, anything like that, the more sort of breadth of what you've played around with, the better. But not everyone's going to have played around with everything or used every programming language under the sun. But that's hopefully you've done at least lots of programming. In COMP6991, we're going to think about programming languages as a tool, right? So instead of just like you enter 1511 and they go, okay, so we're going to be learning C, and you learn here's how an if works, here's how a while works, here's how a function works, that sort of stuff. and you just sort of accept it as gospel. This is how I write programs. Then you go to a different language and they go, oh, okay, we do this slightly differently, but you know, you do this, you do this, you do this. In 6991, we're really trying to think more abstractly about programming languages. We're trying to look sort of from a little higher up and go, you know, here's programming language A, B, C, D, E, you know, well, 2 of those at least for programming language. Actually, 3 of them at least for programming languages. But like, you know, here's all these different programming languages. Let's think about what these programming languages offer, how they intend for you to do work in them. What are things that we like about this language? What are things that we're maybe worried about when we're programming this language? That sort of stuff. So consider decisions in language design and in using said language, right? And a lot of this is thinking about what works well for you and when, right? I'm going to talk about this a little later in the slides, but don't be mistaken in thinking that COMP6991 is a course that is just going to preach about, you know, the one true programming language, Rust. I personally think Rust is a pretty good programming language and it has some stuff to offer. But there's other languages we could have taught this course in. I think Rust is a particularly nice choice for the course because it has a lot of these different ideas that we want to look at sort of joined together in one big package, but Rust has its own flaws as well. And there's sort of scenarios where there's often many better choices than Rust, right? So we're not thinking about, you know, just learning Rust and this is like you know, the COMP6991 is like a cult of Rust. We're adding another option available to us and we're using this to help us think about choices in other programming languages and how we write programs. And from then on, it's up to you to decide what you do, what you use, and you know, in what situations and when you use it, right? Dong enrolled for the cult, so I'm sorry, but yeah, you might have to figure that one out on your own time. So after the COMP6991, what should you sort of expect as a graduate of this course? You should be able to reason about language tooling and design, right? Things you'll have spent a lot of time playing around with different ideas and you'll go, oh, I quite like doing things like this, or, you know, I really don't vibe with functional style, but I can write imperative code way better now, you know, that sort of stuff. You can think about programs as contracts, right? So you should be able to go, if I write a function that looks like this, what do I sort of get from this here? Like, what guarantees can I make about this code? What do I have to consider when writing this function so I don't have to worry about the program blowing up or crashing or causing a memory safety issue, that sort of stuff, right? You should be able to reason about invariance and correctness, mostly statically. So Rust is a nice language in that a lot of the time, if there's some sort of correctness issue, you'll get that warning at compile time. So that's what we're talking about statically here. You don't run the program, you know, it works 5 times and then you put in some different input and it goes, oh, blow up, crash, you know. Hopefully we should be getting these kinds of errors when we're building our code. And from being basically repeatedly punched in the face by the Rust compiler over and over going, wrong, 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 it'll help you to reason about how can I write programs that are more likely to be correct the first time. And, you know, you'll have an additional language under your belt, hopefully. So learning Rust is certainly an outcome of this course. It's not the totality of the course. This course doesn't exist just to teach you Rust. There's tons of great resources online to teach you Rust. We're trying to get a lot more along the way, which is, why did Rust do this? You know, are other languages, how did they sort of make these decisions? What trade-offs were there? Other languages that do anything any better? You know, we're looking at all these considerations along the way, right? Journey, not the destination. You know. Here, let me catch up with the chat a little bit. So more complicated doesn't necessarily mean more difficult. That's a very good point. Rust might even be in very epic web-based emulators, right? Yes, Mipsy, very good. Enroll for the cult. Yeah. That being said, okay, Rust cults. Okay. Mention C++ Rust stations will melt. Well, I sure hope not, because we'll be mentioning C++ throughout the lectures, probably relatively often, including today, hopefully. Option, another option. Yes, very good. Does Ada aim to do something similar? Yeah, for sure. Ada is also a very interesting language. We'll see if we can bring it into the lectures at some point, but Probably not quite widespread enough to do like a ton of coverage on Ada, but we'll see if we can get there. 251 being referred to as a Java course. Yeah, exactly. And like compile time guarantees and safety. Yes, absolutely. Awesome. Perfect. So all caught up. Themes of COMP6991. Program design, programming languages, program safety, program robustness. There's like a Wikipedia link here for robustness in computer science, which was a new page to me. So have a look at this Wikipedia page. It's quite interesting, but it says robustness is the ability of a computer system to cope with errors during execution and cope with erroneous input. So this is going to be a major theme of COMP6991, and a nice little Wikipedia page that also talks about some different principles as well, which is pretty interesting. Very cool. I think I need to go full screen again. Nope, I've got this here. Whatever, that'll do. Cool, so some overarching themes of the course. All right. Easy to fall into the trap of hating or loving a language, even just by making jokes about it. Yeah, for sure. And design patterns, yes, very good. Okay, so in terms of reading for the course, so there's no strictly required reading, and there's no like prescribed course textbook. Some activities may say, here's something that's, relevant and quite interesting to read. I think usually they will be like genuinely interesting. I feel like some courses can do the whole, here's some content, so we'll lean on that for the teaching, and then, don't have to do as much elsewhere. We're not really, we don't plan to use sort of textbooks and stuff or articles to, in place of the teaching. We'll always aim for it to be like, here's a really interesting blog post that we liked, and hopefully might be a fun read. If you're reading it and you're going, this is boring, I'm not interested, then by all means switch it off, right? Go back to whatever else you're doing. They should be interesting and fun to read. And if you don't find it that way, that's perfectly okay. Just, don't read it and do something else. So in terms of, recommended, there is the Rust programming language book. It's often just called the book in Rust. It's available online for free on HTML. You can also order a paperback, if you like, but it's just on the web and free and quite nice to use. The book is excellent. It's a really good learning resource. Shrey's linked it there. Thank you very much. Check it out. See if you like it. If it's working for you, then by all means, but it's not required. So it's just for your own. And then some suggested readings as well. Rust in Action is a great book about systems programming in Rust. It's by Tim McNamara, who will also be joining us as a guest lecturer. We'll be delivering a guest lecture or two later on in the term. So very cool, very excited for that. And also Rust for Rustaceans is sort of a great, more intermediate to advanced level reading by John Jangset. It is a relatively advanced book. My copy also took like I think a year or something to arrive in the mail, so I'd maybe suggest getting a digital version if you're interested, but it might be more suitable for like after COMP6991 for like continued reading, because it is a relatively advanced book. Cool. Tools and systems and stuff that we're going to be looking at throughout the course. The Rust toolchain. If you are installing Rust at home, then I would strongly suggest you use RustUp, as basically does the rest of the Rust community. You don't have to install Rust at home. You can just use the tools on CSE, such as 6991 Cargo, 6991 Rust C, 6991 blah, blah, blah. We've got basically all the tooling you should need. If there's something that you would like to use, a tool that you'd like to use that isn't available through 6991 or anything like that, just make a post on the course forum and we'll install it. No big problem. Crates.io is where we get third-party dependencies. For the most part, you probably won't even realize Crates.io exists if you're just sort of following exercises, but you can look on Crates.io for third-party dependencies and stuff like that where allowed. Rust documentation. So for example, there's a nice link to the standard library. Rust documentation usually gets mostly served out of a site called docs.rs. I am a big fan of Rust documentation and the way it's laid out and the things it encourages, like lots of examples and stuff like that. We'll look at writing our own documentation and all that as well. I think during week 4 or 5, something like that, if I'm not mistaken. And documentation is actually a very interesting part of Rust as well. And we have Autotest and Give, Usually it just means sitting inside the, CDing into the crate that you're working on and just running 6991 auto test or 6991 give. It'll figure out what activity it is and, all that automatically. So you should, for the most part, just have to run this command here and this command here to auto test and or give. Cool. Lectures, like here, like right now. So they're on Mondays and Wednesdays, both are 6 p.m. to 8 p.m. and they're live streaming as we see here on YouTube. Live chat available. Please ask questions. Please make comments. All of that. They are going to be recorded. And there's it sounds like a train is blowing up. The lectures are recorded. They're not linked on we don't have a page for lectures on the course webpage just yet, but we will have one soon. And I'll link slides and stuff on the course webpage also soon. Cool. Lectures focus on the thinking behind different features of Rust, right? As I've spoken to quite a bit at this point. We're often going to feature many programming languages other than Rust. Be prepared to be guided through unfamiliar code, right? Even today, we're going to look at something like 5 different programming languages. It's not expected that you know all these programming languages. You might know one language quite well, probably know C relatively well. You maybe one other language, you've written some big programs in it, and then 1 or 2 other languages you've seen a little bit of here and there. We're going to assume basically zero knowledge about any language other than C. So just try not to get hung up on the gnarly little details unless we're sort of directing attention to them, and just sort of follow the broad strokes ideas that I try and pass along. And I'll help guide you through different languages. Sometimes in the lectures, we'll spend a portion of it teaching Rust itself, right? So even today, we'll do a little bit of Rust programming just to sort of bootstrap things, get things started. But a lot of self-directed learning in terms of Rust, the programming language, is expected. Make use of the resources available, like the book and that. Make use of the course forum to ask questions and the weekly exercises to get practice. There's tons of materials and stuff like that. We only have so many contact hours a week, so you're going to have to spend some time playing around with Rust yourself and getting things wrong and fixing it and asking questions and all that. But we will still spend at least some time in the lectures, writing Rust ourselves and just, learning things in Rust as opposed to comparing things to different languages and all that. Will we be able to access the slides before the live lecture? It's a great question. The answer is maybe. The answer is I'll try. But I can't guarantee it for every week, sadly, but I'll do my best. So we'll see. Okay. Workshops. So each week you'll have a 2-hour workshop. It might be listed as like a lab on my UNSW. This is what we're talking about, the workshops. I believe they're all on Thursdays and Fridays. And we have a workshop every week, 1 through 10, but skipping flexibility week. 3 of the 4 workshops that we have are face-to-face on campus in J17. 1 of the 4 workshops is online, which will be hosted on Discord. You'll receive an email with further information about, if you're enrolled in an online workshop, you'll get an email with more information about the online workshop sometime in the next couple of days. Don't worry, we'll get you there. For now, maybe just making sure you have access to Discord, and if there's any problems there, letting us know. And if you're enrolled face-to-face and for some reason, some week, you can't make it on campus, maybe you're sick, maybe you're away, something like that, then by all means you can temporarily join the online stream, and similarly to the online workshop, we'll email out some details in the next couple of days. And for people going, yay, Discord is mainly chosen for the screen sharing capabilities. It's very good at letting many people share their screens all at the same time, which is something that we care about in the workshops because there's going to be some small groups, right? So the workshops themselves are going to be very practical sessions. They usually focus on a large problem as a class, right? So the tutor might come in and go, today we're going to do this cool thing. Maybe it might be, we're going to write a web application that does so-and-so. And hopefully so each workshop's going to look a little different, but as an example of a workshop, they might go, let's all gather around and work on some sort of design. So we'll go, okay, we're going to need this, we're going to need that, we're going to need this. And it's going to involve lots of stubbing, going like, here's a function, but we'll just leave it to do, right? In all these little parts, work on a big design. Then we'll break up the pieces into very small groups, and you'll go away and hopefully have, 45 minutes, an hour, whatever it is, to sit there and actually practice your Rust programming and to work on a small piece of this big problem, right? If there's extra time, we might even say, you solved this problem this way, maybe try doing it a different way. Rust is often like multi-paradigm. There's multiple ways to achieve a similar result. So we might go, oh, you did this quite imperatively, maybe try functionally. Oh, you did this quite functionally, maybe try imperatively, that kind of thing. And so, playing around with the code and writing, these smaller features, at some point, we'll bring everyone back together and try and integrate the code into a larger project. Hopefully it works. Sometimes it may not work every time, and, maybe there's some fixing, or maybe it's, okay, well, this is what we've got. But the real meat and potatoes of this workshop, the most important part that I really love, is that at the end, once we put this all together, we get in a big circle and we chat and we have a discussion. We go, what parts of this project do we like? Does anyone like, what are some things that really stand out as that was a cool thing to do? That's something that I quite liked. Or, what are some things that were a little, that maybe feel a little shaky about this code? This, parts that don't feel quite as robust that might break down. Are there different ways that we could have done things? Do we have any interesting issues along the way? Was the compiler fighting us about some sort of thing here and there? And really just go through all this stuff. What might this look like in another language? Could we use this, clever type system trick in a language like Python or something like that, right? And we're going to really sort of think about these things and play around with them in a nice big discussion. I seriously think they're going to be really cool. I think it'll be a lot of fun. So let me just quickly catch up on the chat then. Discord, cool. Will there be consultation hours / help sessions available? Think about assignments. So this is still a little bit TBA. The plan is to lean on the course forum quite a bit. But I might see if I can set up some consultation hours, just for smaller bits of help and stuff like that. But we'll have to see how we go. Lost me at group work. Well, this isn't assessed group work, keep in mind. So I'll talk about that in a second as well. Right, yes, that's Alex's question we'll get to in a second. Prereq knowledge on functional programming? Nope, not at all. Don't think Rust is a functional language. It has functional elements, but it's not something like Haskell or Lisp. Yep, correct. Hyped for workshops, basically dream for learning effectively. Great, I'm awesome. It's very glad to hear that. What if I can't attend the first week workshop? I have another event clashing with both Thursday and Friday. Yeah, that is rather unfortunate. So let me say this. Workshops are not mandatory. So in this case, don't worry about losing marks or anything like that. Sadly, we only have the workshops on the Thursday and the Friday. And they don't really make much sense to record. The sort of educational value in them is the actual participation of it. Nonetheless, we might consider recording the online class just as if you really couldn't make it to either and still wanted to see what was done anyway, then we might have that option. But we don't really have many contingency plans in place right now for if you can't make either workshop a given week. So yeah, sorry about that. Cool. Okay, so let me bounce back to this for a second. So in the workshops, the teachers expect that you've watched the current week's lectures, right? So we have the lectures on Monday and Wednesday, and then we have the workshops on Thursdays and Fridays. So those workshops are expecting that you've watched the Monday and Wednesday lectures before the workshop starts, because we might need to build off knowledge that's been presented in the lectures. Again, it's not like a absolute requirement. We're not going to check off your YouTube watch history as you walk through the door. But keep that in mind. That's the general expectation. If you haven't been able to watch the lectures, by all means, still do come along and still do participate. But it might be a little more confusing and there might be sort of some catch-up work during it. Yeah. So it's also, the workshops are not intended as time to work on weekly exercises, and tutors will almost always not have time to help with non-workshop material, right? The workshops really are a workshop. They're not like a COMP6991 lab where sort of tutors just roam around the room, giving help with other content like weekly exercises or something like that. So the workshops are really a workshop. if you have those kinds of questions, that's certainly cool. There's no problem with that, but try and direct them to the course forum instead, which is where we're going to be trying to answer a lot of these kinds of questions. Cool. And yeah, as Tom notes as well, we will encourage publishing the code that results from workshops, so you can also look at them. Absolutely, yeah. So being able to see what other classes have worked on and how they approach things is a really, I think will be really fun. So as we saw here before, workshops aren't mandatory. There is no participation marks. If you don't show up to a single workshop, you won't be given a 0 for the course or fail or anything like that. But with that in mind, please, please, please do give them a try, right? Even if you've heard all that and you're like, I don't know, do me a favor, give them a try. If you go to the first 2 weeks and you decide, yeah, I really don't like them, they're really not for me, then let us know why so we can improve it. But we're not gonna force you to come, and we're not gonna hold you against your will. But I really do think they should be fun, and I think there'll be a lot to get out of them. So if you're on the fence, please give them a try at least for the first couple of weeks, and then make your decision. Is it possible to increase the capacity for the online workshop? I will get back to you, maybe. Like, yeah, as Trey mentions, you're welcome to attend if you can't attend the in-person one. So maybe we can look at bumping the enrollment. We'll have a look. But yeah, I'll let you know later. Maybe I'll let you know next lecture. Okay, so that's workshops. Weekly exercises. So there's weekly exercises weeks 1 through 5, 7 through 9. So note there's no exercises during week 6 and week 10. There's usually going to be several exercises, but they're really substantial in size. It's usually going to be like, here's a small program. Maybe the program is broken and we want you to fix it. Maybe we want you to write something from scratch, something like that. But they're individual tasks, and they're mostly just to practice using Rust. Right, so then you feel prepared and you feel that you know how to use the language when you're working on your larger assignments or in the final exam as well. We will sometimes ask theoretical or open-ended questions, right? So that open-ended could be both a theoretical open-ended question or a practical open-ended question, which may be manually marked. And generally for the weekly exercises, we'll be quite lenient in our manual marking. We usually have auto test available, and you submit everything with Give. There's instructions on the weekly exercises page, that sort of stuff. If you have questions about them, course forum, anything like that, cool. Assignments. There's 2 assignments. Assignment 1, program design, and assignment 2 on concurrent programming. So these are released, actually, let me just double check the course outline before I give faulty information. Assignments. Assignment 1 is due week 7, and assignment 2 is due week 10. That's probably going to be something like week 7 Friday. Oh, I think maybe week 7 Monday, week 10 Friday, something like that. Do we say when they're released? I think I had it written down somewhere, but it might not have made its way to the course outline. But you can expect them probably released. Assignment 1 probably sometime around like week 3, and assignment 2 sometime around week 7. So they're an opportunity to work on and demonstrate your knowledge in a larger project, right? They're going to be relatively hefty, and they're going to be individual and have the standard UNSW late penalty, which is the 5% a day for 5 days, if I recall correctly, but we apply it hourly, which, to be clear, is strictly in your favor. Assignments there will be, and we'll talk more about assignments when they're actually getting released. There is a final exam. It'll be online, right? Online exam, work on it from home. There is almost certainly going to be a mix of practical and theoretical questions, right? And it's probably like the exam is our main avenue to test these sort of theoretical ideas. So expect a reasonable amount of open-ended theory. For a lot of these questions, there's often going to be no right answer, right? Whatever the right answer may be. But so your answers really just must be well justified. We might not be looking for a specific answer, but as long as you argue it well and demonstrate your understanding, then that's basically what you need. And we expect it to be 3 hours centrally timetabled, but we'll confirm that when we have more info. Okay, the usual stuff. Code of conduct, plagiarism, that sort of stuff. I'm going to read it out. So CSE offers an inclusive learning environment for all students. in anything connected to UNSW, including social media. These things are student misconduct and will not be tolerated. So things like racist, sexist, offensive language or images, sexually inappropriate behavior, bullying, harassing, or aggressive behavior, or invasions of privacy. Show respect to your fellow students and the core staff. Like, this is genuinely very important. I'm hoping we don't have a problem with this term, but like, take this seriously. It's yeah, definitely very serious. Plagiarism, cheating of any kind, constitutes academic misconduct and carries a range of penalties. For example, group work on individual assignments is not okay, but talking about it, discussing it, chatting about ideas on the course forum, whatever it is, that's okay. Allowing any other student to copy your work, getting your hacker cousin to code for you, or purchasing a solution to the assignment are all not okay. So just make sure you don't. And labs, tests, assignments. So, the weekly tests and assignments and exam and all that must be entirely your own work. You can't work on them in groups. We will check for plagiarism. Plagiarism is bad. You might get suspended. You might lose a scholarship. You might lose a visa. You might fail the course. Just, don't do this is basically what we're getting to. And yes, Ferris will be very disappointed. That's very true. And there's no past assignments to cheat from. That's also very true. Okay. As far as the assessment goes, it's very simple. 20% weekly exercises, 20% assignment 1, 25% assignment 2, 35% final exam. Look at that one, 35%. And so to pass, you just need 50 out of 100 overall. No hurdles, no, UFs, anything like that. 50 out of 100, you pass the course. Note that every weekly exercise counts. Right, so we don't do like a best 7 of 8 or anything like that at this point. It's just like the exercises get summed up, and each week is worth 2.5%. So there's 8 sets of weekly exercises. Each week is worth 2.5%, which is evenly distributed among the exercises. So yeah, no double pass, nothing like that. So you get 50 marks, you pass the course. Very easy, very simple. Yeah, and academic misconduct bad, and lower exam component. Yes, I also am a believer in that. Okay, so how to get the most out of COMP6991? Attend these lectures. We've got a bunch of us here now, which is I'm very happy to see, and happy to be up in front of everyone. Be involved, ask lots of questions, think about any questions that are posed, and you're all doing great on that so far. Have an open mind. So this is what I was mentioning a little earlier. We're not here to convince you that Rust is the one true programming language. We want you to think about how you program. What works best for you? We will explore many of Rust's weaknesses along the way. And if you leave 6991 hating Rust, but having become a better programmer along the way, that fulfills our success criteria. If you come out of here going, I love Rust and I learned a lot, that's great as well, no problem. But we're not here to convince you on Rust. We use Rust as a tool in this course. And we're just trying to get us to all think about programming and hopefully learn a little more and get something along the way. I also suggest attend and actively participate in workshops. Again, I'm seriously convinced they're going to be really fun. If you're finding that they're not fun and you don't feel like you're getting much out of them, don't just I would really prefer if you don't just silently go, okay, I'm just going to stop going and not do anything. If you can at all think of why or how they could be better, let us know anytime. If you're going to the workshops and you're really enjoying them and you're having a great time and you can still think of ways they can be better, please let us know also. The easiest way to let us know is probably in the course forum. There's like a feedback category, but we might also add like an anonymous feedback form or something like that sometime this week. So whatever works well for you, you're welcome to do. And also work hard on your assessment items, the weekly exercises, the assignments, the exam. Try not to miss anything if you can. It's sometimes you fall behind. There's lots of different things going on in and outside of the course. But if you're working hard, that's the most important thing for sure. Izzy likes the assessment outline. That's great. Slides will be on, I'll get them on the website later on. I'm going to have like a lectures page that we just don't have yet. So I just need to write that up. Final exam. Sure hope the final exam doesn't change the spec halfway. Yeah, I don't think you have to worry about that, fortunately. Okay, yeah, okay. I get the message. Okay. Cool. And finally here, assumed knowledge. So there's some non-negotiable assumed knowledge. Knowledge of C is absolutely requisite. This course is prereqed by COMP6991. So we're expecting that you have, knowledge of C. You've worked on a large project, probably in C, for example, COMP6991 assignment, and a willingness to learn and open-mindedness, right? So if you've got those three, then you're set to join us in COMP6991. Some other stuff that's definitely going to be useful, I think, in this course is experience with a programming language other than C. Even if you're doing another course at the same time, like maybe you've only used C now, but you're taking, some other random course, 2511, 1531, I don't know, whatever it is, and you're learning another language like Python or JavaScript maybe, or Java, whatever. If you're sort of doing another language at the same time, then that's great as well. That'll certainly help out. Pain in programming is useful. Yes. I think this is, maybe Tom can remind me. I think pain in programming is either maybe Carol Morgan's idea, or maybe it might have come from Dijkstra. I'm not 100% sure. I think Tom might know this a little better. But the idea of having experienced pain when programming, okay, is Carol Morgan. So another, an academic at our school at UNSW, Carol Morgan, who teaches primarily these days COMP6721, Informal Methods, the Lost Art, talks about an idea of it's hard to appreciate certain ideas in programming until you've been bitten by them. So what we're hoping is that most of us who have come in here have seen that nasty segmentation fault. Or if you've been using DCC, you've seen the big uninitialized variable access, or, just we're hoping that you've seen lots of error messages and you've had, not to wish for your sadness, but, that you've sort of gone through that and, at least somewhat overcome it. You've gone through frustration when programming. C++ template errors, Sherry mentions. Maybe put your worst programming fear in the lecture chat if you'd like. I'm sure we've all been through this kind of stuff. And so if you've experienced pain in programming, that's what we're trying to think about. That's what we're trying to reason about in this course. Tom mentions the borrow checker. Yes, that's gonna be a bit of a gnarly one. About maybe a third into this course or something like that. Setting up environments, yeah. Template errors are very readable. 1,000 line error messages are great. Python dependency management, programming without using Arch Linux. Oh, great. And if you've experienced different programming levels, like you've written some low-level programs, you've written some high-level programs, you've written some OOP, some object-oriented code. If you've written something a little more extravagant like functional code, often a lot of people will go, no, I've never done functional programming, because they've never touched something like Haskell, or they've never touched ML or a Lisp or something like that. But they go, oh no, but have you used Java's streams? Have you used .stream, .filter, .map, whatever? Or have you used, C++ has similar ideas? Have you used Python's filter map? And you go, oh yeah, I've used those things. And you go, yeah, okay, so you've used some functional programming, you've used these ideas. And so if you've played around with anything like that, that's all gonna bring value to your education in this course for sure. Debugging asynchronous code. Oh yeah, that's gonna be really fun towards the very end of this course as well. That's a development that Rust has had. That Rust has brought, I suppose, which is particularly interesting, I think. Just tried to log into the course forums, got an ACK error not found after trying. Oh, I know exactly what that is. That's not ideal. I'll have to look into that after the lecture, but that's CSE systems being a little frustrating. It's complaining that if you've ever used ACC on a CSE system, it's complaining that ACK doesn't exist on the server right now for whatever reason. So anyway, I'll have a look at that after the lecture. Having to use two functions to pass between a number to another number. Send an email, Fedora gang. Okay, cool. Awesome. So, believe it or not, that's our intro slides right there. So where are we at? We're at 54 past. Yeah, dude, these are some nice quotes. Now that we've sort of got an idea about what the course is about, just to run through them again. A programming language is a tool that has profound influence on our thinking habits. Like, you know, really do think about these things here. Powerful programming language is more than just a means for instructing a computer to perform tasks, right? Really important ideas for this course. And then Larry Walls is kind of just funny. And is it too late to complete the week 0 labs? Oh, right. Yes. Sorry. I should have mentioned the week 0 labs. I meant to do that actually. Let me figure this out. Here we go. I'll get the course website over here. Yes. Great question. So the week, if I go to the course homepage, I'll just give you a very quick tour. We have announcements that come out here. These also get emailed out to you, roughly around when they're posted. So more announcements will pop up here over time, and just keep an eye on your email and you'll get a notification. There's the course forum linked to here, which may or may not be working right now. The course outline and the timetable, which just has the classes, the locations, the teachers, that sort of stuff listed. We have home computing resources. So if you open this up, it shows how you can install the Rust toolchain at home and some guides for writing Rust in VS Code or in NeoVim. Those are the two sort of most popular editors we found for Rust development. You're welcome to use whatever text editor you like. These are just the ones that we have guides on hand for. And if you want to do all your work in CSE, then there's no need to install a Rust toolchain at home either. You can just use 6991 blah. But these are nice. Shrey's written these up for us and he's done a great job. And then we have the week by week exercises, revision questions, that sort of stuff. So week 0, if you look at these weekly exercises here, they are not assessed. So there's no give command. I think some of them have auto test. So just run 6991 auto test on them and see if it works. But they're just intended to get you up and running with Rust, to get you, having written a program or two and know how to print things and know how to use a loop, that kind of stuff. But you can do them anytime at all. There's no deadline. There's no, submission or anything. It's just for your own learning. The first week of weekly exercises is actually like, these are accessible exercises and they have auto tests and they have give. Well, most of them have auto tests. They all have give. And they're due next week, Wednesday. I should note the revision questions. If you look at these, they're pretty similar to, if you've seen 1511, 1521, intro comp tutorial questions. And so we'll release, hopefully at least a couple questions each week just to get you thinking. And at the end of the week, we'll also release answers, which I might need to log in as a tutor for, revision answers. And for most of these, we'll also have a video to go with it, just to sort of walk through a quick solution. Some of them will be like a minute or two. Some of them might be 10 minutes, something like that. But we'll usually have a written solution and at least sometimes a video to go along with it, just for your own revision. Cool. And working access lecture notes, they don't exist just yet, but sometime this week, I'll let you know how it goes. Cool. And yeah, week 0 just helping you also make sure you can even use Rust in the first place, making sure your setup is working basically. Okay. Any quick questions before we go into a break? We'll have a quick 5-minute break or so before we start playing around with some code and looking at some languages. We're going to look a little bit at an option type, right? Very cool. So any quick questions before we go to a break? I'll give, if I don't hear anything by, I don't know, 45 seconds past, we'll start the break. All right. We'll go into a break now. Let me switch over here and we'll be back in 5 minutes around, 4 past the hour. We'll come back and we'll do some coding. We'll look at some languages. It'll be fun. So I'll see you all back in about 5 minutes. Alrighty. Hopefully I didn't mess any of that up. It looks like, oh, it's annoying as the daylight goes down, and also now I'm looking at a big bright monitor. The green screen sort of gets a little unhappy at times, so I apologize. I apologize for that. But welcome back. Hopefully, yeah, I think you should be able to hear me again. So, will I get to 1,000 subscribers? Well, yeah, there's 100 students in this course. Cool. I think Shrey might have made a memes category on the forum, which is good fun. So, let's talk about some quick Rust basics. So, we'll start off with Hello World. Oh, this kind of looks like a nice color background for me. Okay, so Hello World. Let's write some Hello World in Rust. So, when I'm writing Rust, I generally like to have, my terminal that I'm doing work in, whatever that is, whether that's your VS Code, whether it's, Vim, gedit, IntelliJ or JetBrains, whatever it's called, one of them. Whatever you use is going to do just fine for this course. Our suggestion is you use something called Rust Analyzer. Usually most text editors will have some kind of plugin for it. VS Code certainly has a Rust Analyzer plugin, right? That's written like Rust Analyzer, like this. NeoVim has a plugin for it. I think that JetBrains people actually use, they have their own one that works, pretty well as well. But it does make writing Rust a little easier. It gives you little type hints and suggestions and all that. So that would be my only suggestion, really. Other than that, it's completely up to you. And I like to have documentation open up as well. Documentation, especially, I found Rust documentation to be quite nice, quite legible and nice to use. And the easiest way to get to by default, you're probably just going to be wanting to look at the standard library documentation. Obviously, if you start pulling in other dependencies, then you'll want to look at those as well. But just to get to the standard library, you would do docs.rs/std, docs.rs/stud. Is a nice little sort of shortcut to it. Or I think on the course website as well, if you click the ferris in the corner, it takes you to the standard library documentation, which again is quite nice to use. So I'll keep that up on the side here. And let's write Hello World in Rust. So if I want to make a new Rust project, generally we'll use something called cargo, right? So if you're on CSE, you'd write something like 6991 cargo new, and then the name of your project here. Right, so maybe I want to make like a Hello World project, something like this, and you'll see it's created a new binary application, right? Rust programs can either be binaries, which is a program that you run, you run it, it'll do some work, it might spit out some output, something like that. You can also create libraries in Rust, which is just code not intended to be run on its own, code that's helpful to help other people write code essentially. And there's lots of libraries available in Rust. If you were trying to write your own one, you would write it like this. Cargo new --lib, hello world. But we actually want to write a program to run, right? We want to run it and it prints out hello world. So we're going to do 6991 cargo new. And so I'll cd into it. And you see there's a couple files here. So there's the cargo.toml, right? My editor is a little crazy. I haven't fixed it up in a while, so I might have to do that before next lecture. But you can see it just starts us off with some pretty basic info, the name of the package, starts our version off at 0.1.0. It also has this addition here, 2021. I see some people come in here sometimes and go, let me check. No, it's 2022. Let me change that. It's not going to be too happy if you do that. Edition is sort of like the version of the language you're using, and they come out every 3 years. There's a 2015 edition, 2018 edition, 2021 edition for like the sort of big breaking changes. Well, not even breaking, but minorly breaking changes in Rust. Otherwise, there's updates to Rust like every 6 weeks. But we'll try and keep the 6991 Rust stuff usually stays pretty well up to date. So there's no need to change anything in the cargo toml. If we wanted to have third-party dependencies, right, like extra libraries to help our code out, we'd put them down here. You used to have to type them in, but now we can just do sort of cargo add and give it the name of a library, and it'll just go and do it all automatically. But we're not going to do any of that here. We're just going to write a little bit of code. It also just generated a couple of extra files because I ran some cargo command or something like that. or probably just opening my editor did it. It created this target directory, which is where compiled code usually ends up. And also a lock file, which is to do with dependency management. Lock files are very interesting, but probably outside the scope of this course. You'll see there's also this src source directory, which has the main.rs file in it. If we have a look at it, oh no, spoilers. It has nothing in it suddenly. But so we'll write some code ourselves, but you can see it actually did come preloaded with hello world. So in Rust, oh, there we go. In Rust, as a binary program, right? Not a library, a binary that you run, execution starts in the main function. You declare a function with the fn keyword, right? This will be a new function. I give it the name main. I say does it take any parameters? No, main takes no parameters in Rust. And if I wanted a return value, it would go somewhere like this. But main has no return value in Rust. We simply just write it like this. Function main, it takes no parameters and has no return value. We'll look at doing functions and stuff at some point. And now if I want to print something out, well, let me go to the documentation here. So something I like about the Rust documentation is you can just press S, no matter where in the page you are, you just press S, it gets you in the search box, and I'm just going to type print. Let's see, std print, std eprint, std print ln, eprint ln. Right, so maybe printing a line of output is something that we'd be interested in. So I'll go to this documentation here, and it says prints to standard output with a new line, some blah, 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 and an example here. Right, so let's steal this example right here, paste it over there, and we're going to change our text in here to say hello world, like this. So this is something called a macro. We're not going to worry about it too much for now. It's just a thing we can use to us now that looks a little bit like a function, but they're slightly different from functions. We'll get there in like week 7 or something like that. But for now, print ln, we print out the string hello world, and we end our line with a semicolon, similar to something like C. All right. So we've written some code. How can we run it? The easiest way to run your code is just to do 6991 cargo run. So Rust is sort of like C or C++ or Java or Go or whatever you're using, where it's a language that compiles down to, well, in Java's case, it's not quite machine code. It's actually a byte code, but most of the time, we're talking about compiling down to some machine code, assembly, whatever you want to think of it as. And then once we've got that compiled version, we can actually execute that. Rust is very much the same. So if I want to follow that process, I would use 6991 cargo build, right? And you'll see, oh, where's my binary? As I said before, it's actually inside target. We look inside target, debug, and there it is there, the green one, hello world. And if I run this program, then you see, run the program, it spits out hello world. That's great. But this can be a little annoying to do cargo build, find the thing, run the binary. So there's a nice convenient 6991 cargo run, which does both of those steps. It goes and compiles your code, and then it runs it automatically for you. So it just does both of those in one single step. So I use cargo run all the time. There's shortcuts for this sort of stuff. 6991 cargo R will do the same thing. R short for run. B short for build if you're into that sort of stuff. But and if you're doing it from home, you just drop the 6991 at the front. Cargo run, cargo build, whatever it's going to be. So yeah, that's getting our program up and going in Rust. Let's see what I've missed out on for the last little bit. How do you have all that cool stuff at the top of your screen? I think, yeah, Shrey's mentioned i3 and Polybar. Cool. KDE, no. Okay, yeah, so talking about desktops. All right, cool. For clarity, anything with 699 cargo is not something we wrote. It's part of cargo. We've just installed it onto CSE. That's right. So CSE, if you just run cargo on CSE, their Rust toolchain is wildly outdated. I think it's over like 3 years old. And so you'll probably get a message going, failed to parse addition. You wrote 2021. I don't know what that is yet. It just means you've forgotten to put 699 at the front, which is 6991's install of cargo, which is far more recent. It's interesting how many decisions on language design went even into the first line of code shown here. Why use function and not the return type first, right? That's a great one to think about. We won't have time right now to stop and spend too long on it, but think about that one, now and after the lecture. What are the decisions that went into this line of code? What is, in C, let's say main returned an integer, In Rust, we would write that like this. Rust says int as like i32, basically. If we're in a language like C, we'd probably write it like this. i32 main, parameters go here, return values over here, right? And again, idea of this course, think critically. Don't just sort of jump to a snap conclusion, right? Don't jump to a snap conclusion and go, okay, well, I definitely prefer Rust here. That's just so obvious to me. And don't jump to a snap conclusion going, this is different. I liked C. I didn't see a problem with it, right? And so I don't like this. Take a while. Stop. Think about it. Think about how it might affect if, when functions get more complicated. If you end up needing to, like, if you've ever, like, passed a function pointer or something like that in COMP6991 or, stop and think about these things, consider them, and then you can come to some sort of conclusion on this is what I would prefer and this is the kind of things I like. In C++, auto main goes to int. So why is println a macro and not a function? That's a really great question, and I'm going to leave it for now. And same with the what is a macro. It's a great question, but I'm going to leave it for now. Ask on the course forum and we can try and give you like an early explanation, but we don't properly talk about macros in this course until week 7, I want to say. Week 7, maybe week 8. I think one of those. But they're very sort of deeply, a relatively simple idea that has very deep and profound implications. But so I'll leave it at that for now. Ask on the course forum for an early sort of half explainer, but we'll probably get to it later on in the course. And very, very easy to bike shed and say, I hate FN, why not FUNC? Harder to consider, yeah, for sure. So Tom's sage advice right there. Okay. So that was Hello World. Where are my slides? Here. Guessing game. Right. So, guessing game. Yeah, just be for 10 minutes and train on just Xmonad. So this is an exercise that comes right near the start of the Rust book, right? So if I think I've got it over here. This is, let's go over here, I guess. So you see that this is the book here, and chapter 2, they get you to program a guessing game. We're going to do that together here during the lecture. You are welcome to go ahead and also work on this guessing game yourself. But I'll be jumping into the chat and seeing what people are saying and thinking. And we're going to play around with it. So I just made a new, while we were talking, I did cargo new guessing game. I've changed into it, and we can see we've got a new cargo toml here. We've got a new fresh Hello World program that Rust sort of spits out for us by default. And if I run it, we get Hello World printed out. See, compiled, finished, and run. Okay, so the idea of this project is we want to make a guessing game where the computer generates some kind of random number, let's say from like 1 to 100 or something like that, and the user's going to input guesses. They might guess 50, and the computer will say, oh, the secret number is higher than 50. And they go, okay, what about 75? And they go, oh, no, it's lower than 75. What about 62? And, you sort of try and like narrow down the number until you go, oh, 65. Yep, you got it. Great. Nice job. And so we want to write a program that can do this. And this is a great starting program, especially in Rust, because you get to touch quite a few different things. I'm not expecting everyone to completely understand everything that we do here, but it'll give you a feel for the language, right? You'll get an idea of how things sort of start to look. Sorry, I know. Blah, blah. You get a feel for how things will start to look, and you'll get to at least become familiar with some of the ideas in Rust. Right. On the CSC computers, do we need to use Rust up or is Rust C okay? I've been reading the Rust toolchain installation on CGI. I don't know which one is better to use for this course. So we use Rust up in 6991. Rust up is basically just a program that helps you like manage your Rust install and update it and that sort of stuff. When you type 6991 cargo, 6991 Rust C, whatever it is, that's using all the tooling internally. For the most part, we'll be using like 6991 cargo. We were planning to do a lot of exercises in Rust C, but then Shrey remembered that Rust Analyzer really hates not being in a cargo project, and it makes editors freak out and all that. So at the last minute, we had to rush change everything to cargo to make text editors happy. So generally you'll be using 6991 cargo. Yeah. And yeah, no need to install Rust up or anything on CSE because we've got it already there. Rust docs seem to have ... to omit important code. Is the only way to view this by viewing source? Ah, right. So the question is here, like if I have, if I look at some type, let me go like, I don't know, file or something like this. You're going like, I can't see this sort of stuff here. I'm not sure which ... exactly you're talking about. So if you can clarify, I can definitely help answer that one. Okay, so guessing game, right? Guess the number, right? Okay, so let's make our program. We're going to say it's going to generate a random number just to help test things. Let's just say we'll let the the secret number just be equal to 42 for now. Right? We're going to change this later to be random, but just so it's easy to test and so we can focus on the rest of it for now, we'll just make the secret number be 42. And you can see this is how we do a variable declaration in Rust. We say let. We give some name. We'll call this name actually a binding in this case. And we bind secret number to be equal to the value 42. Now notice I didn't have to say what type this was, right? Like in C, I would have had to write something like int secret number is 42. But in Rust, I just wrote let. I could have said let, foo equals some string, right? And my text editor is being really nice here and actually telling me the types of these things on the side here, but I didn't have to write it myself. I can write it myself if I want, and if you do want to write it, you put it here. So you go right after the name here, a colon, and then I say I32. Or over here, I might say ref stir. Again, you don't need to know about what these types really mean and all that, but if I wanted to give it, say what type of thing is, I can put it right here. Almost all of the time, right? Very, very often in Rust, it's able to infer what the type is automatically. And so you don't actually need to manually specify it. You just leave it unsaid and it goes, great, I know that's an I32 because I looked at this, I saw that's a number, and so I figured out what type this is. So it's quite nice. Cool. In what cases do we need to have explicit types? We'll run into them, don't you worry. But I'm not sure if we'll run into them today. We'll find out. But don't worry, you will run into them because the compiler will be upset at you and say, hey, I don't know what type this is. Give me a hint. And then you can help it figure it out. Okay, so if we're doing a guessing game, we're going to need to get guesses, right? We're going to need to let the user input a guess. And so we're going to need to sort of read input from the user. So let me search for read. There's a whole bunch of stuff here. What about read line? Right, okay, standard input, right? So there's this standard input type here, stood in, : read _ line. Let's have a look at this. So it says locks this handle and reads a line of input, appending it to whatever buffer, blah, blah, blah. Okay, you can sort of often skip across a lot of the details if you're not super interested in all the semantics at the time. You just want to go, okay, how would I use this thing first? And have a look at this. Input is string new, read a line into input, and then, here's some stuff, or maybe there's an error. Great, this seems roughly what we want. So let's sort of go along that track. So we'll say let input is a new string, right? Again, broad strokes. There's going to be, oh, I don't know, what is this code here? I don't quite get it. It's okay. We'll just we're just playing around with this for now. We're just getting a feel for the language. So we're going to say IO stood in, oops, I need to, IO stood in dot read line. Okay, let's look at this. So it takes a ampersand mute string. Well, I have this input here as a string, so I guess I can take my input here, which is a string, and just put an ampersand mute here, and it seems, it's happy with that. Okay. And then this function, right? So read line takes this ref mute string, it gives back a result of usize. Oh, a result. Okay. So we can see here that it's saying that sometimes this can be okay, sometimes there might be some kind of error, and they want us to sort of deal with these different cases. Well, we can do that, but I'm going to show us a little function for now that just says make these things go away for now, and that's called unwrap. So we're going to talk about all of this, don't you worry. We're going to talk about all of it, but unwrap here just means I had some thing that could have gone right or it could have gone wrong. I'm just going to assume it's gone right. If it went wrong, crash my program, and we'll think about it a little more later. Okay, so there's a compiler. The compiler's complaining. It's got some red things, cannot borrow, blah is mutable. A lot of the time, it's hard to read these kinds of errors in the text editor with a whole bunch going on. So I just like to run cargo build sometimes and get the bigger output here. So it says warning, unused variable. Okay, we knew that. We're not using the secret number yet, so we can ignore that one. Error, cannot borrow input as mutable as it is not declared as mutable. So on this red line here, it says we can't borrow it as mutable and this @mute input, but it says help, consider changing this to be mutable. So instead of let input, maybe try let mute input. Okay, so let's try that out. Let's see what it does. So instead of let input, we're doing let mute input. And let's see. There you go. Error's gone. Great. So it figured it out for us. So Rust has some very strict ideas about which values can be changed and which values can't be changed. If you've ever heard of things like const, or in Java that would be called final, or are there any other, some languages call it like var and val, or some languages call it like let and var. Anyway, there's all kinds of different ideas for this. The idea that some values can be changed, some values must not be changed. By default, when you just write let blah equals in Rust, it assumes that that variable is immutable. The variable cannot be changed. And if you try and modify that variable or let someone else modify that variable or something like that, it's going to go, no, I'm not going to let you. But if we explicitly say this variable is mutable, this variable can be changed, then it'll go great. No worries, no problem with that. Rust compile code looks like a lot like, similar to what you would see out of C or C++, but it's you'll see some like Rust sort of flavorings around the place. Cool. Okay. So this should, in theory, read a line of input into this string here. So this function basically says I'll take a, some mutable string, right? And I'm going to read a line of input into that. So we should hopefully get a line of input from the user. Let's just test it out quickly. So I'm going to say println, right? Println bang is how I pronounce this. You entered, and how do I actually print out something? In Rust, with println in particular, we use curly braces like this. So that means insert a value here. Which value am I going to insert? Input. So this is sort of like a % code in C. In C, we might write something like you entered %s. In Rust, you would write curly braces like this. In fact, even in recent Rust, you can actually just put the variable inside the curly braces here, but you can't do any like other, if you're going to put it inside the braces here, you can't have any other stuff in there yet. You couldn't write like input +2, or you couldn't write input dot, like trim the text off it or something like that. It'll go, no, it needs to just be a variable or it won't let you. So this way is a little more flexible for now. Oops. This way is a little more flexible for now because you could do something like input.trim and it's fine. So we'll just leave it as this for now. And it says you entered some input. Let's test it out. So I'm going to go cargo run. It says guess the number. I'm going to say foo_bar_baz, and it says you entered foo_bar_baz. Great. Okay, seems to be working. Go away. Okay. So we've got our user input. Blah 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 blah. That seems a little early. I'm roughly following along with how the book would like to talk about this. Let's look at doing this in a loop first. So they're saying, oh, let's go to a random number. Let's hold off on that for now. We've got one line of input, and then the program continues on and it ends. And so we're expecting that the user is going to guess quite a few times, so we might want to do this in a loop. In particular, we might want to do this in some sort of infinite loop, right? In C or C++ or Java or whatever we're writing, we might like to write something like while true, right? We write while true, and then in all of this here, hopefully this just sort of keeps happening, keeps going like this. In Rust, it's worth noting a couple things. First of all, you don't actually need these parens here. So, and it's generally, idiomatically, you wouldn't write the parens. So this is true for while loops. you know, if statements or if expressions, I suppose, you know, anything like that, you don't need the parentheses around here like you usually do. And so we suggest that you just leave them off. Rust also has a nice little sugar for while true. Instead of writing while true, you can just write loop, which just basically means an infinite loop, which is quite nice. All right, yes, decompiling Rust code. And why not use ref input? If I wrote that here, you'll see that there's some sort of error here, and it goes, it expected a mutable reference to a string. We got just a reference to a string. I'm not going to go too deep into this right now because we're going to have a lot of chat about what the implications of this line here are, but we're not going to get there quite yet because there's, again, it's quite a big task and we only don't have enough time in just this lecture yet. Is readline allocating the space for the string? Yeah, so we've sort of created this new string here, which sort of brings about the idea of a buffer, right? A string is expandable in this case, like capital S string that we've got here. It can grow, it can shrink, that kind of thing. And when the user types in the line, it'll actually grow our string here to make space for it and insert the text in that they've written. Okay, great. So this should hopefully work in a loop now. So let's try it out. So foo, you entered foo. Bar, you entered bar. Baz, you entered Baz. Okay. And if I do Control D, it's, yeah, just nothing, no input. So I actually have to kill out of this with Control C because we've got no way to exit the program just yet. Okay. I don't know why. Okay, there we go. That's better. So what do we need to do next? Well, hopefully the input that they give us should be a number that they're guessing, right? There should be a number that they're guessing. So it'd be nice to turn that into a number that we can compare against the secret number here, right? Against this, the secret number 42 in this case. So first of all, we need to, before we can compare it, we need to turn this string here into an integer. Some languages might let you compare strings to integers, you know, just as they are. Not so happy in Rust. Rust likes to be quite explicit about things. So let's turn this string into an integer. And the easiest way, I know how in this case, is to use input.parse. Parse is a really nice function. It'll basically turn it into, you know, if there's some sort of definition that input can be parsed into blah, whether that's parsing it into a number, parsing it into, you know, some other random type. If there's some sort of definition for it that exists, then it'll be happy to do it for you. So we're going to say let number equals input.parse. This is one of those times where it's going to go type annotations needed. Because what do we want to pass it into? Maybe a number, but maybe we want to parse it into like a, you know, a student. Maybe this is some JSON definition. Maybe it's Python pickle, right? Maybe it's just some random text that is, you know, that we'd like to parse into some completely different idea. So we need to tell Rust, no, I'd like to parse this into a number. Let's just say I32 in this case, which is sort of the canonical int. And it's going to go, nope, I can't quite do this because it could go wrong. Parse is potentially fallible. So it's going to say, if you want an I32, what you really mean is that you want a result where the success value is an I32, but there also could be some kind of error. This is a little bit of a cheeky, weird way to write it. For now, I'm just going to say parse also will let you specify it a little like this, right? Parse me into an I32, and that'll probably look a little more familiar for now. And for now, again, we haven't talked about this quite enough yet. Result, meaning it could be a number or there could have been some error that went wrong. The magic function that just says, I'm just going to assume it went right for now is just .unwrap, like this. And so now number should truly be an I32, which is what it's saying here. So number is the number that they typed in. If they typed in something that really just wasn't a number, that it couldn't turn into a number, then it's just going to crash the program. It's just going to blow up. And for now, in a, you know, baby's first program, we're completely fine with that. No problem. Okay, now we want to compare these numbers. Is it bigger? Is it lower? Is it the same? So we probably write something like this. We'll say if number is less than the secret number, else if number is greater than the secret number, else, and this is sort of like, you know, if the number is equal to the secret number, right? The only remaining case here, then they've guessed the number. So we've got our sort of three cases here. So I'll fill them out. If number's less than the secret number, then we'll say println, you know, guessed too low. If the number is greater than the secret number, then we guess too high. Otherwise, you got it. Great. But if you got it, what do we want to do? If you got it, do we want to like, do we want to loop around again and keep getting more guesses? No, probably at that point we're saying, all right, you've got the answer. So similar to a lot of other languages, there's this idea of break in Rust, which my editor is not happy with because I missed a semicolon in all these places here. There's an idea of break in Rust, which just means end this loop. We're done with this loop. Return would also work perfectly fine as well. Yeah, return from the whole main function because we don't have any code here down the bottom. So will this work? Let's try it out. Cargo run, guess the number, 50. Thread main panicked. Result unwrap and it said invalid digit. Ooh, big bang. So this is, you know, I was saying we're just going to assume it works, and if it doesn't, then blow up the program. And it's saying invalid int error. Does anyone have a guess what went wrong here? How come I typed in 42? Yeah, okay, you guys are all over it. Right, so there's a new line on the end of my input. I typed in 42 and 50 and hit enter, which is 50 and then a new line character. So it's not happy about that. So I'm going to add a trim here before I actually parse it. Trim out any white space on either end. So all right, let's give that a go. 50, guess too high. 25, guess too low. 42, you got it. Okay, great. So we've got a bit of a guessing game. It's always 42. And we're going to swap this out for a random number in a second. But I have a quick question. Does anyone have an idea of how, like this line here is fine, right? And also Shrey's just mentioned there's the trim documentation. Again, just over here, I can very quickly get to this documentation here and go, here's an example of how you might use it and what it might do. Very cool. James is mentioning match, right? So this here is not quite idiomatic in how you'd write Rust, because you could get these if conditions wrong, and there's already code that's sort of, you know, well vetted that knows the intent we're trying to express here. We're trying to figure out how these two numbers relate to each other ordinally, right? Whether it's greater, less, the same. And we've written that quite imperatively here. We've written it as like explaining to the computer how to do that, how to compute which one is which, right? But in Rust, we would generally prefer to instead describe what we're trying to do, to describe the problem that we're faced with, as opposed to telling the computer how to do it, right? So there is something called compare, right? Compare, when we have two things that can be compared. So look at this, 5.compare 10, 10.compare 5, 5.compare 5, and you might get some sort of ordering. Let's look at an ordering. An ordering is either less, equal, or greater. Right, so let's try this out. There's lots of examples here to make use of. So if we said number.compare to the secret number, and it's my editor's smart and it's going, hey, you know, this is what you mean. You just want to put an ampersand here. Again, we'll get to that eventually. But this will return us a ordering, which is one of these. It's going to be less than, equal to, or greater. And Rust gives us this amazing operator to deal with this, which we'll look at more next lecture, called match. So I say match on this ordering here, right? Match on this ordering, and I can say fill my match arms out for me. And it'll say, sorry, the editor's going a little crazy here for now, just bear with me. It'll say, what do you want to do in each case? Right, it's putting all this std comp ordering here because, you know, it's like, I don't know what ordering is. I can just put a little import statement up the top, std comp ordering, and then get rid of all this extra like fluff here. But if I swap these for braces, give me a second here to sort this crisis out. All right, there we go. Now look at this. Instead of telling it how to do it, we've said compare these two numbers, and it's given us less, equal, or greater. Right, so let me just put this same code in here. Right, again, this code is doing the exact same thing. Actually, we need 2 lines there. Right, code's doing the exact same thing, but it's a completely different way of writing it. Now, which one do you like better? That's up to you. That's up to you to figure out. And we're going to play with all kinds of examples. You're going to have plenty of time to figure out all of this stuff. But it's worth knowing. It's worth thinking about and using both methods. Right? Again, really just about playing around with things. Let's just double check it actually works. 50, 20, 42, you got it. Great. So it literally does the exact same job. Exact same thing. And, you know, take a look at this and see what you think. Right? Think about, this is the kind of time where you think about how often do you mess up a little if condition? Where you go, oh, was this less than or equal to, or was this side greater and that one was less? Especially if you get into like an or, you have this thing or that, or did I mean it's this thing and that, or, you know, what did I really want here? Yeah, as Chelois, I'll figure out how to pronounce that one, mentions, would match be better since it's exhaustive? So yeah, one of the things that match gives you is that it is exhaustive. So you need to account for every single case. If I forgot about the fact that the number could be greater, I'll actually get an error at compile time. I won't actually be able to build my code. I'll get non-exhaustive patterns, greater is not covered. And it says, hey, you should put in a match arm that checks if it's greater. And there are ways, to be clear, you might go, oh, okay, I hate that. Sometimes I don't want to deal with those. There's ways to tell the compiler I don't want to deal with that other case, but there's something in there. There's something there that says that says you have to explicitly say I don't want to deal with that case. So, you know, since match is required to be exhaustive, it's recommended to use, especially if you're using a custom enum that might change later. Yeah, for sure. Right. So we think there's less equal greater. You know, what if you're using some other enum, you know, some other, you know, set of possible values where later you go, actually, there was another option that I needed to add here. In another language, you might have to go and try and track down every single spot where you were dealing with this thing to now account for that other case. In this case, if you wrote it like this, you build your code again and it goes, okay, so you're missing it here, 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 and there. And you can sort of track these things down. And yes, that's one thing, Haskell as well. Haskell is non-exhaustive. Haskell has very similar ideas of this pattern matching, but it doesn't require exhaustiveness, and that can be a real headache to work around as well. And match also compiles to jump statements in certain cases more efficient. I think in this case, it's probably pretty likely that they compile down to the exact same code, whether you did the if statements or this comparing, if you turn on like optimizations and all that. So often it actually doesn't matter which one you use. This is a principal idea of something called zero cost abstractions, which we'll talk about during the course. Yeah, often it just comes down to which way communicates your idea better. Which way are you less likely to write the wrong code? You know, these are the things to start thinking about. So I think the last thing we have to do here for this guessing game is to make this not just be 42, but a random number. And I believe we have a crate called rand to help us out with that. Utilities for random number generation. So over here, I'll write 6991 cargo add rand. So this will add a third-party dependency of rand for me. Apparently it wants to update my crates index, so we have a little bit of time while it works out on it. I said the word zero cost abstractions. Yeah, it's an important idea. Okay, there we go. So I've got rand. It doesn't actually update this index every single time. I don't know why it chose to do it right now, but it did. And it's talking about some features. You don't need to really worry about these at this point in the course. But the important thing is, if I look at the cargo.toml now, you'll see it's included this here. Rand is 0.8.5. So now we can use this library in our code. So instead of writing 42 here, we'd like to get some sort of random number. They've got a quick start. To get you started quickly, the highest way to get a random value is to use random or thread RNG. We'll just use thread RNG here. So we'll go, rand thread RNG dot generate, return a random value supporting the standard distribution. Great. I'm gonna steal. Oh wait, no, I went way too far, didn't I? We're doing things a little bit out of order. Cool. There we go. Gen range is probably a little better for us here, which I am, again, to be clear, stealing. And we'll generate a number in the range of 1 to 100. So this should give us a random number. And instead of writing 42 here, we're basically just going to stick this bit of code right there. Perfect. So this should just be a random number between 1 and 100. And can you combine ordering and a condition to deal with a greater than or equal case? That's an awesome question. And just to show you what the code would roughly look like, I think the chat's sort of already all over this one. But you can write these sort of pattern matching, which we'll talk about again next lecture as well. They're quite flexible in that I could say something like, oops, not like that, something like this. Right? If it's less than the number you guessed too low, if it's equal or greater, then you got it. So it is certainly possible. Okay. Do we always add a dependency when we use something outside of the standard library? Yeah, pretty much. Pretty much. If you're looking to use external stuff, then you'll have to add it as a dependency. Can we use underscore? Yes, absolutely. We'll talk about that one more next lecture. All right, so let's see how this goes. You can see it was building these extra dependencies that we pulled in here. We asked for rand, but rand itself has its own dependencies that it needs to pull in, right? That we can see over here. And so it had to build some extra programs to get ours to run. So I'm just going to guess 50. 50 is too low. 75 is too high. 62 is too high. 57 is too low. 59, we got it. And we see if we run it again, will we get a different number? Yeah, 50 is too high, so you can immediately tell that it's, you know, that we've got a new number here. 42, 40, you got it. Great. Okay. So yes, there is a lot going on with this program here, but the important idea is that we're not expecting you to look at this and go, yeah, I get every single line of this code. Easy, no problem. But we're hoping that you look at this code and go, okay, I can sort of tell that's Rust. You're going to get a lot of practice writing Rust code, and these things will come to you. But as long as you go, okay, I can sort of start to pick out different little bits and pieces. I see how this roughly looks like C. I see how this might look a little bit of like another language I've used maybe. You know, just picking up on the broad strokes. That's the idea here, not to understand each little bit of code. It's just to let you watch someone write some code in front of you and get a little familiar. Okay, so that's our little guessing game. Let's rush through the sort of last bit of stuff we have to talk about. So we have structs and enums, which we've talked a little bit about both of these. I don't think we really talked about structs much. Oops. Oh my gosh. Yeah, editor going crazy. So to be clear, structs are very much like they are in C, right? Very similar idea. If I have a struct student, then I might say the student has a ZID. I might say the student has a name. I might say the student has a WAM, you know, that kind of things. It's just about combining multiple types together into one large type like a student, and you'll get practice using structs and playing around with the fields and that sort of stuff. So worry not. So yeah, structs, much as you know them. Enums are a little bit of a different idea, which we've started to look upon. So an enum, I might give this one, you know, a name. Let's say enum COMP6991 member. So an enum lets us express the idea that there's different possibilities for this type, right? Just like this ordering that we saw here. So in ordering, it's either going to be less, equal, or greater. And we saw that they defined it like this: enum ordering less, equal, or greater. Now, same idea. If a COMP6991 member, they might be a student, they might be a teacher, they might be an admin, they might be a lecturer, they might be a convener, something like that, right? So all these different possibilities. The really key important thing with enums in Rust, and this is similar to some languages like Haskell, any language where you have something called sum types, this is essentially just a sum type, SUM, is that you can also attach data to each of these things, and you can attach different data depending on which one it is. So for a student, we might care about a student has a ZID. So I'm gonna write it like this. A student has a ZID, which is, I guess I've been modeling that as a number recently. A teacher might have, you know, a name. which is some string. An admin might have like, they have a name, but they also have like hours worked or something like that, how many hours they spent administrating. Lecturer might have, you know, a name, hours worked, and also like the, you know, lectures delivered. Right, we can have different data types depending on which sort of version it is, but they're all unified under this one name here, COMP6991 member. So if someone goes, here's a COMP6991 member, well, you're not going to be able to do anything with it until you check which one it is using something like this match, right? Using match here. So let's say we got a student, we would go match on this student. If it's a student with this ZID, then do this. If it's a teacher with a name, then do this. If it's an admin with a name and hours worked, then do this, and so on and so forth. And yes, U32 is just an unsigned 32-bit int. And it's incredibly useful when writing programs in Rust. And we'll leave it to you to decide whether you end up liking enums. But there's one enum in particular that I'd really like to end this lecture off looking at. And that's an enum called option. So let me define option myself right here. Enum option, it's really simple. The one weird thing is that it has this T up here, right? And it says some T or none. So this T here is basically saying that if I can't just have an option on its own. There is no such thing as just option. There is only option of something. Right, so in this case, we might think of something like an option of int, right? An option of i32, or maybe like an option of string. And this T here can be swapped out for any type. It could even be swapped out for some other option type. If you really wanted, you could say something like option of string or something like that. The key idea is that option requires another type to go in between these, you know, these little brackets here. And that wherever this T is over here, it gets substituted in as well. So yes, this is generics, absolutely. Is this maybe? Yes, this is maybe if you've come from Haskell, if you're seeing crossovers from other languages. Yes, great, perfect. That's exactly what we want. And please tell me these generics are better than templates. It's for you to decide, but I have a feeling you might be convinced. So this is the option type, and you'll see that the option type is either one of two things. It's either some T or it's none. So it's either this variant here, and these names could be anything. This could be a variant foo and a variant bar. The really important thing that distinguishes them is that foo carries a T along with it, carries, you know, in this case here, carries an int. In this case here, carries a string with it. But if it's a bar, there is no T. Right? It makes a lot more sense to think of this as probably these names, some and none. But this is a brilliant, this is a pretty brilliant idea, I think. And it exists in a lot of languages, which is, this is a type that represents a value that may or may not exist. Right? If I have an option of i32, you know, let's say my function takes an option of i32 as a parameter, then I have to check it each time. And sometimes my function is called, it might be, yeah, here's that integer. Or sometimes when it's called, it might be there's no integer at all. It's just none. So in other languages, you might be starting to think about some ideas like null, right? You might go, oh, okay, this is some sort of type that represents either it's there or it's not there, right? And I think I've done that with null before. Sometimes when I'm passing a pointer, I'll pass a pointer to an actual thing, or sometimes I'll just pass null, which means that I might be using that to signify that there's nothing there, right? It's a very similar idea. But we're going to think about like what that looks like and why I prefer one way or another. Okay, so option. So I've got a program. I have a lot of programs here actually. I've written roughly the same program in a bunch of languages: Java, C, C++, Go, Python, Rust. Since we have assumed knowledge of C, let's look at the C version first up. So what does this program do? If we start at main, it calls this create function. Create takes a Boolean, right? True or false. If it's true, it returns a string hello there. But if the Boolean is false, then it just returns null. In this case, this is how we write it in C, but what I'm really trying to communicate here is that if it's true, it will return a string. If not, it won't return a string. It'll return something that means there is no string. In C, this is generally how we'd write it. We'd write it as a pointer, right? String is a char star. And if there is a string, it gives the string. Otherwise, it'll give back null. So then how would we deal with this in C? If I create true, and I put it in this variable here, before I use it in C, I must make sure that I always check if it's not null. This is a bit of a, I've written it like this, but maybe you'd much prefer it to look like this. If create true is not equal to null, then print it out, right? Or another way you might do this in C is with something like a ternary, right? And I might write this as well. Create false is not equal to null. So if we now create a false value, which should give us null back, print out, it returns some string. If it's not null, this is the ternary operator basically says, ask a question here. And if it's true, then do this thing. If it's false, then do this thing here. So if it's not equal to null, then yeah, sure, go ahead, print out that string. If it is null, then print out empty instead. So let's see how it works. It says create true returned hello there, create false returned empty. Okay, so it seems to work. Does anyone want to jump in with is there anything that you feel a little, sussy about, is one way to put it. Is there anything here that you look at and you go, I'd be a little worried if I was programming in this code base? What would be your considerations when you are writing this main function, right? When the lecture is sus. I'm going to show you lots of sus code this term for sure. So yeah, if we were working this code base, you're at your job at Google and someone says, hey, here's this function create that returns a pointer. Return is highlighted in red. What would you be like, what would you be thinking about? What would you be potentially worried about, in this code base? Just looking at the function definition, it's not clear that create could return null. Yeah, for sure. Right? This just says returns char star. A lot of people look at char star and they go, great, string. And they go print it out and, suddenly they're printing null. They get something called undefined behavior and things are going horribly wrong. Right? There's no way to distinguish between an empty string and null. I think you maybe could, but it's certainly unclear, right? But it's still just like really tricky. Basically forces you to always check. Right, that's a really good point as well. Basically forces you to always check for null if a type return is a pointer. Right? Yeah, empty string is going to point to a null byte character and null is 0. So all these things sort of get mixed in the same bag and get quite confusing. But so that point, it forces you to always check for null if a type return is a pointer. That's a really scary idea. Whenever you call a function that, say, returns a char star, or if you define a function that takes in a pointer, as a parameter, wherever you get some unknown pointer, it always has this possibility to be null. Right? This might be an idea that you're just sort of like, is ingrained in you. You're like, yeah, that's how coding works. And with some of these things that we look at this term, that might be the case. And so that's why I say you got to keep this sort of open mind and think about these things. Because yeah, that's the case with a lot of languages, right? So let's look at a couple other languages here. I've got some C++, for example. So C++ does have this std optional type, which is quite a bit like Rust, right? And we can either return, there's some string hello there, or there is the empty option, right? There's nothing. And we can do similar things. Check if it's true, print it out, or we can do it a little more functionally like in C, where we say, give us the value out or print out this empty string instead. But we still often have to worry about the same problem in C++. If you're using pointer types like exist in C, you always have to check if they may be null or not, right? If you're using modern C++, even things like std unique pointer and stuff like that, still have possibilities to have poor values in them, right? Effectively null. And so you end up having to program really, really defensively, right? Defensive programming. You have to go, this could go wrong, this could go wrong, this could go wrong, and sort of account for every possible case. You know, could this pointer be null? Could this pointer be null? I spit a pointer back out. That person then needs to go, was that pointer null? Right? Anytime you're dealing with these values that could be nulled out, there's possibility for like something to go wrong. There's possibility for some kind of a crash, right? Same thing happens in, say, Java, right? Java is a brilliant example because it has this optional type here. But in Java, any single object can be null, including optional itself. So this optional type has 3 possible values. It could be some value. It could be a valid optional object that has, you know, none, nothing, or the optional itself could be null. So there's 2 ways. And it's just like, man, if you ever go into a code base, you're at Google or you're at Atlassian or something like that, and you find an optional that's null, let me know. Send me an email, because that's just like really funny that it completely defeats this whole purpose. But there's just so much to worry about. Even Python. Python is probably the scariest of the bunch, because in Python, any single value in Python has the ability to be none, has the ability to be nothing. And so anytime you get any value in Python, it might be tempting to go, I better just check if that's none or not, right? And it's Python with type-ins. So absolutely, you've seen that like languages develop over time, and they've all, you know, there's been sort of convergent evolution where people are starting to realize maybe there's some ideas here, maybe there's some things that can help us in terms of like safety and all that. And I think it's for good reason. That's why we're sort of inspecting these kinds of things here. So there are mitigations in languages, but a lot of the time there's still pitfalls that sort of fall through, and it's important to understand where the language might let you down. Right? Learn how to use MyPy and never look back. Yeah. And so that's, you know, one of the things that's been advancing and is becoming more popular these days is type systems that help us avoid these kinds of ideas, right? Avoid these kinds of problems. And so, you know, with things like MyPy, with things like TypeScript, with, you know, Rust, with quite a, you know, powerful type system available to us. And yeah, it looks friendly to use, but in terms of reverse engineering, it's a horror move. Even in terms of just writing correct software, it can be really difficult, because you're always worried about what could go wrong, right? I think my absolute favorite has to be Go in this case, because I had a real fun time writing this example out, because first of all, Go has no ternary operator or anything like that. So I have to create a variable and then go, if it's not nil, then that variable is the thing. Otherwise, that variable is this string. And then the other really fun one is a string itself. Although a string is implicitly a pointer, the string type can't be nil. Go calls it nil, not null, but you know. So you have to do a pointer to a string, but you can't actually write reference hello there. The Go compiler doesn't like this line of code, and so you end up having to pass this string to a function that just does that for you, and it's just beautiful. It's just brilliant. So you know, even trying to do the right thing or trying to do these things correctly can be a hassle, and that can actually be dangerous, because people tend to go with the most, you know, the frictionless route, whatever is the most clear to create code. And so if you make it hard to do the right thing in your language, that can also be a real hazard. So that was certainly a fun one to write. But let's come back around. What does the Rust code here look like? I would write something like this. Okay, it's freaking out. Sorry about that. Okay. Stupid text editor. Okay, we're going to open it in something else, because this is just horrible. Okay, great. So in our Rust code here, our function returns an option. This is just a Rust's way of saying string in this case. And we say if it's sum, then return hello there. If it's false, then return none. And we can write something like this. We say create true. If it's something, then grab it and unwrap. So this should feel a little iffy so far. We check if it has something in it, and if it does, then we call this unwrap function, which we've seen a couple of times now. It means I'm pretty sure it's okay, and if it is, if I'm wrong, crash the whole program. It's like there's a little bit of communication going on between these lines. If I messed up what this was, then this might crash the program. As it's written, it's probably fine, but it feels a little scary. So, you know, another method might be create false and unwrap it. Or if it's, you know, if it's doesn't exist, don't crash the program, just provide this string instead, right? So this was the sort of 2 methods that I tried to do in each programming language. But then down the bottom here, I have this sort of hidden third option, right? Down the bottom here, which says, I don't know why the color just messed up. It says match, right? Match some string. If it is some, if it has a string, then print out that string. If it doesn't have a string, if it's just none, then the amazing thing about this, the thing that I really like about this personally, is that in this none case, there's literally no variable called string, right? This string here is only valid inside this case here. In the none case, there's no variable. There's nothing to get wrong. If I wrote, string in here accidentally, the compiler would go, hey, that doesn't work, right? There is no variable string. That was up here. So that's something that I like to sort of stop myself from shooting myself in the foot. But I can see the people are chatting about all kinds of things in the chat here as well, talking about programming languages and stuff, and that's great news. That means I'm loving that that's happening there. And yeah, it is basically Haskell pattern matching, but exhaustive is the one sort of primary difference. Yeah, absolutely. Okay, so there's all those different things. To recap these different types, Rust's option is not a magic type, right? Notice we can write option ourselves. It's not some sort of special feature of the language that only the compiler writers can actually create this type. Anyone could make their own option. You don't even need to use the option that they've given to us. But the important idea is that there's no implicit language nullability. That's something that I forgot to make really, really clear. The brilliant thing about having no nullability in your language and just using something like an option type instead is not the option type itself, right? The option type is sort of just like a necessary thing. We need to sometimes express the idea that this value may or may not be there, right? We just need to do that sometimes. The thing that it gives us by sort of writing our language this way is that it means that anything that isn't written option, if I write string, if I write int, if I write student, like struct student, whatever like that, if I write that, it will not be null. It will always be there, right? I never need to check, is it none? Is it null? Is it nil? Whatever you want to, whatever flavor of the month it is, right? If I get a value out of a function, if I take a value into a function, if I don't write option, then I don't need to worry about the possibility of it not being there, which is a really powerful idea. It's something to consider, something to think about. So Rust, there's also no possibility of causing a crash unless you call a function that explicitly may crash the program if the option is none. And if you do make the mistake of unwrapping a none option, it'll unwind the program. That's sort of like an exception where it's, goes up and goes, you were in this function, then you went to this one, then this one, then this one, then that line, and that line there crashed. And it gives you some sort of like little stack trace saying, here's a line that went wrong. In C, we use a type pointer. The problem with C is that any pointer can be null. Dereferencing a null pointer is undefined behavior, which I would argue is worse than unwinding, worse than causing a crash, because it can lead to memory safety issues, which can let the hackers into your computer and wreak havoc, do all kinds of horrible things. Usually it might be a segmentation fault, but it can be really bad if the optimizer goes crazy. We'll find time to talk about this, or maybe forum posts or something like that later in the course, but it can get real nasty. And so you need to be really defensive when you're programming. You need to go, check is this null, check is that null, check is this null, that kind of thing. C++, similar to Rust option, but similar to C, if you call unwrap on a null option, it's by default undefined behavior. So it can be a little dangerous, can lead to some bad things. Similar idea, pointer types have implicit nullability, and other types like stud, unique pointer and stuff also can have this implicit nullability problem, meaning sometimes you have to program quite defensively. Java, similar to Rust option, but any object in Java can be null. Even optional of T can be null, which is, again, a little scary. And if you find that in the real world, if you've run into this and just banging your head against your desk in 3 years' time and you go, I remember Zach said something about that, please send me an email because I'll love it. Go, pointer to a type like C, any pointer can be nil, but at least dereferencing a nil pointer causes a crash instead of undefined behavior and potentially memory safety issues. Using pointers can be painful though, so sometimes you might write code that you're not the most proud of that may be a little more dangerous. And so you got to be defensive in Go as well. Python is certainly life on the edge. Without MyPy at the very least, without some sort of type hinting, life on the edge. Any value in Python can be none, and unwrapping a none value causes an exception. At least not memory safety once again. So just to wrap things up, what does an option value even represent? Well, it might mean this function might not produce an output, right? So if we have a function that takes a string and turns it into an integer, not all strings are going to be valid integers, right? And so we notate that with option of I32, right? If we write an I32 there, they can guarantee that they're always going to get an I32 out no matter what string they give in. By writing option here, they are forced to deal with the case that it might not be so. A function may not require an input, right? Imagine int a string. Here's our integer and we're trying to turn it into a string, but let's say maybe we let them specify the base. This might be default, like it might default to base 10 if they don't provide it, but they can optionally say, yeah, I'd like to change the base to be base 16 or base 8, for the conversion. But notice this string here is not optional. Any number, right, any integer should be able to be converted into text, and they don't need to check if the string is null, right? They just go, oh, string, great, print it out. What is it? And it'll always be there based on the way that we've written this function, right? This is the contract of the function. The contract specifies this string will always exist. It's quite nice. And you may imagine a struct, like a type that may not have some data. So like a student may always have a ZID, and a student may always have a name, but they may not have a WAM. Like let's say it's their first term, they haven't completed any courses yet, their WAM is sort of like undefined in a certain sense. And so the WAM might not exist, and you might use an option for that sort of thing. So how does language design make writing robust programs easier? Well, if you design your language to not have implicit null types, nil types, whatever it is, and there are languages that do this, right? I believe TypeScript does this relatively well. Things like Kotlin, Rust in our case, Haskell, there's all kinds of languages that do this, these days, but there's also lots of languages that don't. It can make, you may have to program really defensively in order to be as robust, if that makes sense. And we're just going to end this off with Tony Hoare's $1 billion mistake. This is a really great talk that I would strongly suggest watching. But Tony Hoare says, his apology in 2009, I call it my $1 billion mistake. It's the invention of the null reference in 1965. At that time, I was designing my first comprehensive type system for references in an object-oriented language, ALGOL. ALGOL-W, actually. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler, but I couldn't resist the temptation to put in a null reference simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. So if you Google InfoQ, Tony Hoare, $1 billion mistake, there's a whole talk that he does, explaining the sort of considerations and the decision behind it and all that. But it's brilliant to watch, and it's something that I would really strongly suggest you spend some time thinking about. Anyway, welcome to COMP6991. We look forward to the rest of the term with you, and we hope this sort of like bit of a kickstart. You've gotten a bit of a flavor of what we care about in the course and what we're going to be looking at, and we're very excited to have you all. And so I'll just quickly, let's call this the end of the lecture. I'm going to catch up with the chat really quickly because it's been a little while. I had to sort of schmoove because we're obviously a little over time. But let's see, Python type in, scary, yes. Python lets you write super confusing code, but also very clean and readable code. All right, and now we're chatting about Python and stuff. There's some metaprogramming things you can do in Python that would be literally impossible in a statically typed language. There's some very cool metaprogramming ideas that we're also going to see in Rust when we look at macros as well, which will be quite cool. That's a very interesting and deep topic. Classes that dynamically generate classes. Yeah, cool. Okay, so lots of chatting about programming languages. That's great. That's exactly what we want to see. And then we got lost in the source and went, okay, what are we talking about? Kotlin has null. Just nullability must be explicitly defined with a question mark character. So yeah, and that's a pretty similar idea to like something like option in Rust, where we have the idea of a value not being present, but we need to specifically say that this value is optional, may not be there. And the thing that brings us is that all the other things that aren't option or aren't question mark, maybe in Kotlin's case, will be there, and we can rely on that, which is awesome. Please share your Vim config and plugins. Sure, I can make a post on the course forum. Or actually, yeah, make a post on the course forum asking, because I'm sure there's lots of other people who might want to share their sorts of stuff. Yeah, I can do that. I don't think it's too complicated, but sure. How hard is this class going to be? We don't 100% know yet, right? We're still just working things out the first time. On a scale of HCI to AOS, let's say, I'm hoping it's going to be somewhere in the middle, to be honest. I don't think it's going to be an AOS, right? It's not going to be a complete cakewalk, obviously. There's going to be work in it. But I don't think it'll be an AOS. I think it'll be, I'm hoping that people find it either sort of somewhere around the middle, maybe on a little harder side, at least for our first session here. But we'll check up and we'll see how things are going. We'll check in with everyone, and you can leave feedback, and we'll figure it out for sure. Cool. Thank you, everyone. Thanks, everyone. We'll get extra marks using Arch Linux. I use Arch, by the way. Great. Okay. Thank you so much, everyone. Thanks for coming. And I'll see you all again on Wednesday. We'll be looking at some more interesting stuff. We'll be looking more at pattern matching, a little more about those enums and structs in detail, doing some more Rust code. It should be fun. So I'll see you all on Wednesday. Ask questions on the forum. That's right. Yes. The YouTube comments are closed. There's no commenting after the lecture. So that's not to stifle the discussion. That's to move discussion to the course forum, where we'll be happily answering plenty of questions. And please introduce yourselves. Yes, there's an introduction thread on the course forum. And Kai, I need to... Oh, it won't let me... Hang on. Make moderator. There we go. Yes, introduce yourself in the course forum, ask lots of questions, and otherwise, we will see you all on Wednesday. Bye for now, and thanks again. See you all later.